Okay, ladies and gentlemen, so starting with the lesson that we have, 7.2, common factoring, what we're going to do is we're going to factor. Now, that's a very specific word in mathematics, and it's an operation. Just like distributing is an operation and division is an operation, to factor something is to express a number as the product of two numbers. So if we were to have the number 15, and if we wanted to factor 15, we could factor 15 into being 3 times 5. So these would be the factors of 15. Okay, so it's been factored into the product of two numbers. So when you go this way, you get the product. These two multiply together to give 15. When you go this way, you get the factors. Okay, now there's more than one way to factor 15. Another one would be to factor it as 1 times 15. That also is factoring. It gives you different factors, but the product would still be 15. So we're going to have to sort of wrap our heads around this idea that things can be factored in different ways. They can have different factors to them, but when we multiply them all together, if we multiply everything together, then we're going to end up with the same product. So once again, going this way, taking 15 and breaking it up into things that multiply to give 15 is called factoring. And it's a process. And coming this way back, taking 3 times 5 and getting 15, taking 1 times 15 and getting 15, that's called the product, okay, or multiplying, or whatever we want to call that. But that gives you an end result that's a product. Now, factor also means to express an algebraic expression as the product of two or more algebraic expressions. So this little example here was good for numbers, but if we were talking about algebra, as we saw in the introduction lesson that I did for this, maybe I have two algebraic terms. Now we could write it like that, or we could write it like this. These are two terms that are being multiplied together. They are factors of the product of 3x plus 3. So if I was to take 3x plus 3 and put it in this form, this would be factoring. And if I come this way and take these factors and put them into this form, this is what we call the distributive property. And just to be absolutely clear that we understand all the processes that are going on here, in the last lesson that we had, we talked about being able to distribute binomials with each other. So maybe 2x plus 3 and x minus 1. So here are two factors. We can distribute 2x times x gives us 2x squared minus 2x. 3x minus 3. And this will give us 2x squared plus x minus 3. And so that we understand each step here, what we have is the distributive property, and this part here is the simplification, collecting like terms. So simplifying. Also collect like terms. And so we had a negative 2x and a plus 3x. So if I have 3x's in my hand and someone comes and takes 2 of them away, that leaves me with 1x. All right, so that is what we're talking about when it comes to expressing an algebraic expression as the product of two or more algebraic expressions. So this has been factored. What we have here is 2x squared plus x minus 3 can be factored into those two factored forms. So this is the factored form. This is the expanded form. All right, so if the area of a rectangle is given as a polynomial. Oh, wait, I think I jumped a bunch here. So we have an arrow here. Some polynomials can be factored by finding a GCF. Now, a GCF is a short form of talking about a greatest common factor. We'll talk about that in a minute. The GCF for a polynomial may be a constant, a variable, or both. And the area of a rectangle is given as a polynomial. So if the area of a rectangle is given as a polynomial, factor the polynomial to find the possible side lengths of the rectangle. Okay, so there's a bunch of things going on there. First one, let's talk about some polynomials can be factored finding a GCF, a greatest common factor. So let's take a look at 3x plus 3. Now that has a common factor in both of them of a 3. If we look at this a little bit differently, it's 3 times x plus 3, and if we want, we could have a 1 there, just as a placeholder. You'll notice that both of them have a multiple of 3. The x is being multiplied by 3, the 1 is being multiplied by 3, and that gives me 3x plus 3. Well, what we're trying to say here is that we could common factor, we could take what's common in both of these, the multiple, which is the 3 in both of these terms, we could put it on the outside, and this would be equivalent to what we have above. So if we were to distribute, the 3 would go to the x just like it was, and the 3 would go to the 1 just like that it was, and it would give us 3x plus 3. So what we're saying here is that we can, if we know a little bit about the factors, be able to take a binomial and factor it into two factors, and in this case it would be 3x plus 1. Now we are going to remember that there's no difference with writing it like that, but for simplicity, we're just going to write it like that at times. Okay? Now, what we're also saying is the GCF may be a constant or a variable. So here you can see that the GCF that I took out was a constant. What if, however, I had a new question that was, let's see here, how about 3xy plus 3x? So it's very similar to the one that we had up above. The only difference is I have 3xy plus 3x. So what's common? Well, if we think about it exactly like we thought about the one above, so instead of 3x, we make it 3x times 1 as a placeholder, and we see that we have this 3x term that's common in both terms. So we could common factor that out, and that would leave us with just the y and the placeholder. Now what that means is that if I have 3x plus y, if I have 3xy plus 3x, it can be written as 3x y plus 1. And we can see that by expanding, and we would come up with 3xy. The 3x would be multiplied by the 1 and would take us back to the original. And so what we have here is two factors from the original, but now the factors are not just a number value like they were in the example before, but they have a variable term in them as well. And the last thing that it's talking about here is the area of a rectangle is given as a polynomial. So if I tell you that maybe the area of a rectangle is given by this, that's the area of a rectangle. Well, we know that area of a rectangle is given by length times width. So if I was able to take this and factor it into this form, then I could assign one of the factors to be a length and the other factor to be a width. So if we look at this again the way that we were, we could say, okay, there's a 3 here, there's a 3 here, let's put in the placeholder of 1. So what we've done is I've just written it differently so I can see that 3 is being multiplied by the x to get 3x, 3 is being multiplied by a 1 to give 3, common factor, since they both have a 3, let's take that 3 out in front of the whole thing, and that'll leave us with just the x plus the 1. So this is now equal to that. And the difference is, if this was area, then I could assign one of these to be length and the other one to be width. And I could draw a diagram to represent this as perhaps if we wanted length to be the long one here, we could say that's 3, and we would say that would be width. But there would be nothing wrong with us assuming that x plus 1 might be longer than 3 in most cases, and then that would be 3. Both of these would be fine. And these little hash marks means that these sides are the same length, right? And that's the definition of a rectangle. And the area inside would be given by 3x plus 3 units squared. Okay, so we're going to do a bunch of examples now. I'm going to stop there just so if I make a mistake I don't have to redo the whole video, and then we'll continue on.